Hey, Trevor Matthews here with another morning coffee with Trevor. Saturday morning is fantastic morning to have a coffee and enjoy the morning. I've been having a great few days, learning so much, sharing knowledge, and it's been fantastic. Uh, the more I do this, the more that I feel like I'm learning. So it is a lot of fun, and I've been really enjoying it. And today I'm going to continue on with the conversation yesterday. I was talking about flood back, and we didn't dive super deep into it. We did talk about the ways it happens, compressor, running, and that liquid comes back to the compressor and then cause damage to the bearings. Um, but other things that you can see when your compressor starts to flood back, or you can notice when you get to a site and the compressor is not running, or if it's tripped off, or you turn it on and the breaker trip, a lot of times that stator could start running um, against the rotor because the bearing's real sloppy. Joel, how are you doing?
Hi, good morning, Trevor.
Awesome. So
Yeah.
yeah, I'm going to continue on to talk about flood back. So that's kind of really what happens. So the bearing starts to wear. So what happens? That whole rotor starts to get sloppy, and it'll start hitting the stator, which will lead to that electrical failure. Like I've said over many of the talks I had the last few days, is 80% of the time we'll see an electrical failure or a burnout, but that is caused by that mechanical failure. That electrical failure is a second cause. Mechanical is the first cause of failure. So it's just things like that that you need to understand when you're talking about mechanical failures and electrical failures. You need to know the difference. And I didn't dive into it too much yesterday either, but talking about different ways compressors get liquid, and you need to understand those. And I did talk about it a little bit, but um, when you say liquid cause the compressor to be damaged or to fail or to have issues, you need to understand that difference. Was it liquid flood back, flooded starts, slugging, whatever it is, you need to understand the difference. And when you start understanding those difference, your troubleshooting and your skill level on troubleshooting compressor is going to grow immensely. Um, One thing that I want to bring up is I've been getting a lot of calls and emails, a lot of support from a lot of different people. So I really appreciate that. But there's a lot of people that don't really know what I'm doing right now with Refrigeration Mentor. So I kind of want to go through that a little bit. So really, my business it's a refrigeration training company. And what I do is help contractors uh, grow their business by delivering high quality technical training to their technicians and taking them from like a good technician to a great technician. My core offering right now is supermarket refrigeration. So I'll do a supermarket course and I will customize it for the contractor themselves. I also do a compressor masterclass. And so this is something that I really believe that more technicians need to spend time on, is learning compressors, because as I said it 2 days ago, um, I thought I was a great troubleshooter on compressor. I thought I understood how compressor, what makes them tick and how to troubleshoot them. But I really realized after I worked at a manufacturer for many years that, man, I didn't know enough to help my customers out. So that's why I really developed that compressor masterclass. And I'm working on a CO2 course, a CO2 refrigeration course, because I know CO2 is going to be something that is going to grow over the years. It's already here, and I see it already that there's a lot of technicians working on it, and they do not understand what is happening. Why are the pressures so high? What's the safety things that I need to look for? How do I charge a system? And it's all electric. So my real goal is to really help a lot of the contractors, understand how to work on CO2 heat pumps, understand how to work on supermarket racks or parallel racks or small CO2 condensing units. And so I'm developing that. So that's the core courses of my business. And what I do inside those courses, I will work with the technician. So if a contractor purchases a course from me, I will work with each of the technicians and find out where they're really strong at. So what are they strong in refrigeration or in HVAC? And then I'll find out where they need to build their skills. Like, where do they want to get better at? And then that's where I will build and customize the course for the contractor, because if I just go out and just do the training, a standard training for a, a contractor, and I don't know the needs of the technicians for that specific contractor, I don't believe that they're going to get the best value of the training. So that's why I really want to work one-on-one with those technicians with inside that organization and help develop and mentor them, and then challenge them along the way. That's the whole purpose of Refrigeration Mentor, is to, help them grow, help challenge the technicians, and really help that business grow as well. Because at the end of the day, when that business is growing and that technician is growing, that business is going to grow. And I've seen it time and time again, when you have solid technical technicians, technicians that can have good customer service skills, showing up time and, looking out for their customers, you see those businesses grow. So Joel, I'm not sure, I just seen you shot me a message there. You want to just unmute and ask the question, or if it's private, you can shoot me a message afterwards.
Yeah, it's private. Yeah, it's private.
Okay, yeah, let's talk afterwards. Yeah, so that's like the real part of my business, and my mission is really to help technicians globally, like really bring a sense of, of welcome to the industry, build that confidence and that growth. Because I was there, I was a technician in the field who was nervous, who didn't have a lot of confidence, and it took many years, even after I was a journeyman and had many years in the field as experience, it still took many years to build that confidence, because there was a lot of times I was just out there working all by myself, trying to figure stuff out, and I didn't have someone guide me or mentor me or help. And really, there was always a phone call away, and a phone call away is okay, but it wasn't like I sat down and spent time with somebody who, besides my buddy technicians that were probably at the same level or just a little bit ahead of me, which was great, which really helped me grow. But I didn't have someone who was in there for 10, 15, 20 years ahead of me, who was able to talk about me and recommend me to go do training here or do this and guide me in those ways. It was totally up to me. I should have had more initiative probably when I was first starting out. But now I have that, and I really want to help contractors, technicians, and refrigeration professionals grow. I have a lot of contractors as well asking, can you help out like my engineering team, or my design team, to help brush their skills up in refrigeration. So working towards that as well. But my core business is really training, education, and mentorship. So we'll get back to some technical topics. We talked about first a bit of contamination. We talked about overheating. We talked about flood back. The next one that I really think is important is flooded starts. Flooded starts, I talked about it a little bit. It's really anytime that compressor is off and that refrigeration, or the refrigerant, inside that system migrates to the coldest part. Refrigerant attracted to the coldest place in the system. So if that compressor at any time is the coldest part, that refrigerant wants to go there. That's why in refrigeration applications, you'll have pump down systems where you want to pump everything out of the low side so you don't have migration happening. And when that happens, the refrigerant will travel through the system, it'll get into the compressor if it's cold part, and then all of a sudden that refrigerant, that gas or that vapor will condense. So droplets of refrigerant will go into the oil, and then it'll stratify. That's what they call it. It'll stratify. So anytime if you ever go up to a system and the compressor's off and you look into the sight glass of the compressor and it's over full, like it's above the sight glass, there could be a good chance that it could be liquid refrigerant. It could be still too much oil in the system as well, because when the system's off, you shouldn't have a full compressor. But there's a good chance, especially if it's cold, if it's on a roof and you're in Canada like I am, and it's like -20 out like it is right now, it could be refrigerant, right? So you need to be aware of that. And so the things that to help with that are like crankcase heaters, pump downs. You can do bump starts as well. Like there's newer technologies out there. And I know some older technicians showed me how to bump a a compressor properly before. You have to always be safe. You always have to be safe in the field. It's easy in our industry to get hurt, but you have to think before you do stuff, especially when you're messing around with pressures and electrical. You have to be safe. But they have like bump start cycles now. So if you ever out on a condensing unit, all of a sudden it just starts up, and it starts up for 2 seconds and it shuts down for 15 seconds. You're like, what just happened? And then all of a sudden it starts up again and it shuts down for 15 seconds. Then again, it starts up for 2 seconds and it shuts down for 15 seconds. There's probably a good chance that you have a bump start cycle in there, and then it starts up and it runs. And really what that's doing is you're trying to flash off that liquid refrigerant in the compressor. So it's not just one big, and you get to have a slug from that flooded start. Because in refrigerant cooled compressors, as I mentioned before, a major flooded start causes a slug. Go ahead, Joel.
Yeah, well, actually, the Husman have some units that they do that, some self-contained.
Yeah.
They call them the wide Husman wide TY. Yeah, TY cases. Yeah,
TY
they
cases.
actually do that.
Yeah, I'll have to look those up. But yeah, they'll have special control. I know Dixell, when I worked at Emerson, they had lots of different controllers that had that feature in it. And yeah, and I see other manufacturers starting to implement that strategy, because it helps protect the compressor. Is flooded starts one of the largest failures of compressors? No, but it is one that causes it. And it's one where you'll put your gauges on, say, a semi-hermetic, and you'll look at the gauges, and all of a sudden, oh, I'm not getting a lot of compression ratio or a lot of compression. What's going on here? So you pull off the head, and then you got a busted rod, or you got a busted piston, or a discharge busted. You have not as much capacity. Say you got one rod broke out of a 6-cylinder compressor. It's still going to be pumping, but you're not going to get the capacity that's needed maybe for that specific application. So it's important to look inside the compressors. Once again, I can't stress it enough. Not enough of us technicians are looking inside compressors, and you do have time. I know when you're in refrigeration, you have that 15 minutes, you have that 20 minutes. If the compressor is not working already, if it's dead, it won't start, it trips the breaker, blows the fuses, you got to find out if it's a dead short first. You know what I mean? Is it a dead short? Is it wiring? I've seen this so many times where technician, I even did it, they go from the contactor. Oh, it's the compressor going from the contactor, but there's so many times it's those wire leads that shorted through or rubbed through. So you always got to isolate the compressor, shut the power down, lock it out, tag it out, go down to the compressor, pull off the terminal leads. This takes time, and then do it right from the compressor. Because if you had a flooded start in a scroll compressor, we'll say, it busts the scroll set, piece of that scroll right underneath the scroll, it's a stator, pieces of that fall down into the stator, and the compressor, every time it starts, there's still vibration, it still shakes a little bit, and then it makes its way into the winding and it causes a short. And you turn on the breaker and boom, okay. So you go from the contactor, okay, I got a short, or a grounded compressor, then you go pull the wire leads off the scroll. Okay, I got a grounded compressor. So that compressor is grounded when you're going right from the leads. I would always still pull off any motor insulator, terminal insulator. They're usually black. Pull those off, because those could be busted themselves, have carbon tracking. But when you go from the contactor and it's a short, or it's a ground, and then you go from the compressor itself and it's grounded, you need to pull those leads off, because I've seen it time and time again. It's the contactor that's the issue. It's the wire that's the issue. If you're replacing compressors, you need to be replacing the contactor. You need to replacing the electrics if it's single phase. And that terminal plate on compressors like Discus, or in the Bitzer ones, the little black terminal plates, insulator plates, I've seen that many, many times on both compressors. Doesn't matter the manufacturers, where you have carbon tracking, it causes damage. So I got a question here. What about the discus compressor diagnostic check for compression ratio check? Same method applied for recips. Yeah. So the big thing in on a discus or even, yeah, Copeland Mobile, use Copeland Mobile, go there, and there's actually a diagnostic feature in there. And then you can put your suction, your discharge, your amps, your volts for that specific compressor, and it'll tell you if you're running in the operation envelope. Um, so use that diagnostic feature in Copa Mobile. And the same thing, you can go into the Bitzer website, you go on the Bitzer software, it's a little bit more work, but you put in your information into the sidebar of that specific compressor, and then you press play on the performance, and it's going to show you if you're you're inside the envelope or outside the envelope. Lyle, did that answer your question, Lyle? If it did, if it not, just shoot it back into the chat. So it's very important to take your meter and check to see if it's actually the compressor, because time and time again, compressors go back, and it's something simple as that terminal insulator. One good one that I've seen lately is, okay, go ahead. I see your hand up there.
Yes, thank you, Trevor. So when you mentioned about operating envelope just now, so
yeah,
I realized that some compressors, like let's say low temp compressors, are being used for medium temp. So I've been trying to figure out why, and I don't just know the reason why. Like the low temp compressors have been applied on the feed for medium temp application.
Okay. So one of the reasons could be is that they can't get that specific low temp compressor for the application, or for the medium temp. Sorry, they can't get the medium temp specific compressor for that application. So there's lots of extended medium temp compressors. So it could go from 45 Fahrenheit all the way down to minus 25 Fahrenheit. So it can do low temp down to minus 25, but it can also do medium temp. A good example could be on a scroll compressors, ZF compressors. They can go all the way down to, depending on which model, I think it's all the way down to minus 40, all the way up to plus 40. The thing is that it's going to cost you a lot more if you buy a low temp compressor to go into a medium temp application. Because you can, for an example, if you have a ZB compressor or ZB compressor, the way they say it in the US, that's a medium temp compressor, or it could be a medium temp compressor. But if the wholesaler or supply house doesn't have that one, you need to get your customer up and running. So what's the solution? So not sure if that's the case, why they're using those ones, but 100% you need to make sure that compressor is inside the envelope. So you go into Copa Mobile or go into Bitzer, whatever the compressor is, and then you check to see where you're at in that envelope. So was that compressor in the envelope, the one you're talking about?
I was not able to get that because I checked the Copeland PSS software to size the compressor, but because the compressor is low temp, so I couldn't even size it for my application.
Okay, so what you need to do is go into PSS. That's the great place to go. Put the model number in, and then if you put plus 20, say into 20 Fahrenheit or whatever, just say it's 32, 0 degrees Celsius. If you put that in there under the temperatures, and all of a sudden nothing pops up, you're outside the range. If nothing comes up, you're outside the range. Usually it should pop up and say you're outside the operation envelope rate. The next step is to go into the performance chart. So on PSS, if you go to the right-hand side, it's going to say performance. So if you click on that, it's going to bring up the performance chart. Then you can look in there specifically on that performance chart for that specific compressor. It's going to tell you, it's going to show you your condensing temperatures and your SDT or SCT, and then it's going to have your saturated evaporator temperatures or your evaporator temperature on the top. If you don't see where you're at in that operation envelope there, that compressor cannot be in that application or should not be. Will it work? It'll probably work for a little bit, but it's going to start to overheat. It's outside the envelope and it's going to lead to a quicker failure.
Thank you.
If that makes sense. So yeah, make sure you always check to see if it's the compressor that failed electrically, or if it's the wire harness, or if it's the contactor. Change the contactors, or buy rebuild kits, because I know in when I work in supermarkets or market refrigeration, those cost a lot of money. The contactors cost hundreds to thousands of dollars depending on how big it was and how big the compressor was. So you might have to pull it apart safely, look inside and see if there's any pitting or contact, and see if it's still good inside there, because you may have to replace that, and you should. So it's important to check that stuff. Other things to prevent flooded starts: make sure that that compressor is in an ambient that is either a warm or ambient. I've seen it where you have to have multiple heaters in a condensing unit to keep the oil warm in the compressor. Because if the compressor is off for a long period of time and it needs to start up, and you don't have the bump start, and hopefully you do have a pump down, but if you don't, you need to make sure that oil stays warm, because oil becomes very viscous. But the big problem with that is that if any refrigerant's able to travel back to that compressor and stratify the oil and start up, you're going to cause issues. And we talked about it already, is that refrigerant's a good solvent. And what happens when it explodes starts up, it explodes and it washes oil off from everywhere. So if it gets up into the cylinders of a semi-hermetic, it cleans the oil from there, and it's always supposed to have an oil film. So if it's cleaned oil, you get metal on metal, and then it leads to other issues. You can get blow-by happen. You get broken crank, broken rods, sometimes even broken crankshafts I've seen, not too often, or cracked crankshafts I've definitely seen. And you may have to add an extra heater. You may have to add heat to the condensing units itself. They have blankets out there to add heat, because if you're below -40 all the time, I know way up in northern Canada it gets really cold, and I've heard lots of I've had a few friends who said they'd have the crankcase heater plus a blanket to keep it warm. Were you able to answer the viscous compression ratio? So yeah, so Lawa, what you need to do, so that compressor diagnostic check for a compressor compression ratio check, you want to go into Copeland Mobile if you have it, or PSS. But Copeland Mobile, go into the diagnostics feature of that specific compressor and put in your suction, your discharge, your amps, and your volts, and it should tell you if you're in the operation envelope of that compressor. If not, you go to the performance chart. So it doesn't matter what compressor it is, go into the performance chart. If it's a Copeland, go into the performance chart. If it's Bitzer, or if it's a Danfoss, make sure that the pressures that you're running at are inside that envelope of the compressor. Hopefully that answers your question. Yeah, so make sure if you need to move that compressor to a warmer room, or if it needs to be add an extra blanket, you need to do that. Talked about pump down cycle. There's also something that I've learned over the last couple of years that I didn't know, is that refrigerant is chemically attracted to oil. So that's something that it's really important to understand. So even though we don't talk about we talk about coldness all the time, refrigerant's chemically attracted to the oil, so it wants to go to the oil. So there is an application engineering bulletin that Copeland has that is a refrigerant to oil charge ratio. So I highly recommend looking that up and reading. I can't remember the number of that book, but it's that manual, but it's something to check out, because if you have too much oil in the system, it's gonna lead to issues as well. Okay, I'm glad that answered your question, Lowell. Oh. Don't see any other questions in the chat, but it's all right. So that's flood back. So understand that, and there's other things that you can look for, other things that you want to make sure, because you could have lots of different valves in a system. You could have liquid injection valves that could be bleeding by, solenoids that could be bleeding by, that cause flooded starts. You could have, and that's something that is not very noticeable. At times, maybe it only happens or sticks, like the solenoid sticks sometimes, so it flooded starts, so the compressor's cold sometimes. What doesn't protect the compressor? So accumulators, we get into that a little bit. Accumulators protect against floodback. So anytime the compressor is running and liquid can come back to the compressor, that's why you have an accumulator, and it has to be sized correctly. And it protects against floodback. But if that accumulator is full of liquid refrigerant to protect a compressor from floodback, it doesn't protect against flooded start. So all of a sudden, if that accumulator is full of liquid refrigerant, but the compressor is colder than that accumulator, that liquid refrigerant will turn into a vapor, and that vapor will travel into the compressor, condense, stratify, and then you could have a flooded start. So that is something that you need to understand too. The accumulator doesn't protect against flooded starts or slugging. It just protects against that flood back. And you need to, there's a lot of things that you need to check when you have an accumulator, especially if you have a burnout. And I'll talk about this again, is that if you do have a burnout, you should probably change that accumulator, because it has happened to me before where I've replaced the compressor burnout. I thought I did this amazing job. Like I did everything right. Like I pulled the gas out. I've changed pulled the compressor out properly. I did a great evacuation, pulled it down below 500 microns, had it held there. It didn't raise up over 1,000 microns, put in a new dryer, changed the contactor, did all this stuff. Then I went in and I started the system up, and I checked the superheat through all different conditions after a pull down, after defrost, after curtains or doors. Was it curtains? I think it might have been door case, and made sure the superheat was good and everything looked great. I get a call like 3 or 4 months later to go back to the site. That compressor was failed again. It was failed because that accumulator the orifice was plugged from all the buildup of contaminants from that bad electrical failure or burnout. So just be aware that if you have a bad electrical failure on a condensing unit, say, and it has accumulator, you probably best bet to put that in your quote, and replace that, and be very detailed in what the things you need. I know there's a lot of times that we're like, oh, you got to change this compressor in 4 hours, or you got 3 hours to do this whole compressor replacement on, like, say, a 5-ton condensing unit. Like, it takes longer than that to do the job properly. All right. And then it's your job as a technician to take a lot of notes. Okay, I need a new compressor. I need maybe some oil. I need an acid test kit. I need some silfloss. I need a accumulator maybe. So you need to check all this. I need the electrics. I've noticed on new purchase of units, they are coming with accumulators. Should the accumulator be insulated? Okay, that's a great question. Some people say, oh, it should be insulated. Some people say it shouldn't be insulated. Okay, so if it's insulated and the accumulator is the coldest part, well, that's going to stay, the refrigerant should stay in there. Some other people say, well, it shouldn't be insulated. So it all depends who talk to. I would say insulated the accumulator, but there's going to be some people that say don't insulate it. The best bet would be talk to that manufacturer of that equipment and ask them the question, why are you insulating the accumulator? Okay. Same with the receivers. You're going to see receivers now insulated. Okay, especially if they're outdoors and they're usually heated receivers now.
Oh yes.
You're going to see them have some sort of heat strip on them. And they'll be insulated. So hopefully that answers your questions. Got another minute here before we jump off and enjoy our beautiful day and finish our coffees. Well, once again, I want to thank everyone very much for attending another morning coffee with Trevor, and hopefully I'll see you all again tomorrow, and let's get a conversation going. Have a great day.